Nice. Well, thanks so much, Jake. It's really awesome to be with all of you guys. Beforehand, we were reminiscing about how much we wish that we could all be together in person. But unfortunately, the world is the way that it is right now. So I'm thankful that that you guys put this meeting on every week so that we can share stories like this. So as Jake shared, I'll be sharing my journey chasing my cure. And I want to highlight at the beginning what I mean by chasing my cure. And really what I mean by it is chasing cures from many different perspectives. The first is, this is a picture of my mom and I shortly after she was diagnosed with brain cancer when I was a freshman in college. And watching her battle with brain cancer really inspired me to want to dedicate my life to chasing after cures and treatments for patients like my mom so that I could help people like her. Unfortunately, she passed away about a year after this picture was taken due to her cancer. But I think about her every day, and that really set me on a path to hopefully take care of patients like my mom. So fast forward several years to when I was in medical school and third year medical student training to become an oncologist. I wanted to treat cancer patients in memory of my mom. This is a picture from that. And then you can see a picture from just a few weeks later when I went from being this healthy third year medical student to experiencing multi-organ failure. My liver, my kidneys, my bone marrow, my heart, and my lungs began to shut down, all for an unknown cause. I was experiencing what's called a cytokine storm, which up until recently, very few people had heard of cytokine storms, but with COVID-19, that's a term that many people have heard of because with COVID, the most sick patients experience a cytokine storm. And so I was experiencing a cytokine storm for an unknown cause and experienced multi-organ failure, even had my last rites read to me right around the time that that photo was taken. When I relapsed on the only drug in development, I decided I'd dedicate my life towards trying to find a treatment, maybe a cure as a researcher. And I learned that there was no way that I could make progress against this disease on my own, that if I really wanted to make progress, I would need to become an advocate and a connector to try to bring together an entire community of people to make progress for Castleman disease. So I'm going to go back I shared back right around the time that I started college. This is a picture of my mom and I from my high school graduation. And shortly after the picture was taken was when she was diagnosed with brain cancer. And I returned from Georgetown to come back to see my mom. And I remember passing by this wall, and on the wall at Duke Hospital, it says, "At Duke, there is hope." And I remember getting so much comfort from seeing this sign, "At Duke, there is hope," and saying, okay, we're in the right place. My mom has this awful form of cancer, but there's hope here. They know how to treat this disease. This is the same picture I showed earlier, and she battled brain cancer so valiantly and just with so much grit and resilience, and it was amazing to watch. And before she passed, I promised her that I would dedicate my life to working on identifying treatments and cures for patients like her. And that's, as I mentioned earlier, what set me on a course to become a physician. And these are two photos I showed earlier as well. The one on the right being from when I was at the hospital of the University of Pennsylvania, the same hospital that I'd been treating patients at as a physician. Now all of a sudden, a physician in training. Now all of a sudden I was the patient in the intensive care unit who was nearly dying. As was mentioned earlier, I wrote a book called Chasing My Cure about my journey going from this healthy med student to really first just surviving. That was the most important thing. Could I survive? And if I could survive early, then maybe I could identify a drug later. So throughout my talk, I wanted to share a number of excerpts from the book that I thought really get to an important point from my story. So I mentioned that I had my last rites read to me, and I've really considered that moment when a priest came into my room and administered my last rites to me because the doctors didn't think I would survive, to be the start of my overtime. And I think everyone has an idea for what overtime feels like. Overtime is when the clocks run out, but now you have extra time you didn't think that you'd have, but time that's really, really precious, time where you don't know how much longer you will have. And so I've really felt like I'm in this state of overtime where the clock is ticking. I don't know how much time I will have. And I think overtime can be really scary. I mean, not knowing how much time you have can be terrifying, but can also provide clarity. And so I just want to read this passage. The experience of being in overtime is surprisingly one of intense awareness and scrutiny and clarity. There's a reason for that. When there are only a few seconds left on the board, all distractions disappear and the purpose, victory, becomes clear. The present is only the things around you, and overtime is all present, nothing but present and purpose. So I know a little bit about overtime as well because I played college football at Georgetown. And unfortunately, we lost a lot more games than we won or went into overtime. But I did learn a lot during that time about teamwork in particular and what it's like to be a part of an effective and maybe even you could say an ineffective team at times. But these are lessons that would become really critical when I was developing a team to try to survive. I also met my wife during college, and at the time, my girlfriend. And of course, I would go on to need her and her support so much over the coming years. But when I was in the hospital and when I was experiencing multi-organ failure, I had actually, Caitlin and I, my girlfriend who I showed earlier, had broken up just a few months before I became sick. And so all of a sudden there I was in the hospital experiencing multi-organ failure and just regretting with everything in me how I could have possibly let the last few months go by without Caitlin. Why didn't I fight for a relationship? I've only got, I only had a few months left and I didn't fight to make it work. And I thought about this concept of what I call think it, do it. And that's based on the fact, and I'll read here, it came from the very simple realization that the regrets that ate at me the most as I prepared to die weren't about anything I'd done. My greatest regrets were things that I had thought of doing, but never did. It's the absence of memories that you wish you had made and the realization that you'll never get the chance to make them. So I regretted that I hadn't made those memories with her over those last couple of months because I knew I would no longer have time to make memories with her. And so I decided if I were to survive, if I made it out of this, that I would think it, do it. If I thought of something, if I wanted to do something, I would do the best I could to actually make it turn into reality. So around the time of the diagnosis, around the time of having my last rites read to me, I received a diagnosis, idiopathic multicentric Castleman disease, which is a deadly immune system disorder where basically your immune system attacks and shuts down your vital organs. I mentioned in many ways very similar to the most severe COVID patients. With my Castleman disease and all that I was going through, my multi-organ failure, I needed multi-agent chemotherapy just to save my life. So I got a combination of 7 different chemotherapies at maximum tolerable doses. And thankfully, the chemotherapy saved my life. You can see a picture here of me and my dad together. I'm smiling ear to ear because I'm just so thankful to be alive. And you can see my dad's actually resting his hand on my belly because my belly was so big from all the liver and kidney failure I was experiencing. I gained fluid all over my body. At one point, 70 pounds of fluid everywhere due to the organ failure. You can see my belly here again on New Year's Eve with my dad. So this is about 5 months after I first became sick. I was hospitalized for almost an entire 5-month period, but I was finally diagnosed, finally given treatment, and finally feeling better. So I mentioned this is New Year's Eve, and we went for a walk at about 8 p.m. that night around the around the hospital. And as we passed the family waiting room, we saw that there was a guy who was kind of like going back and forth in his chair. He clearly had been drinking too much that night. He just was kind of like swaying and was drunk, and it was New Year's Eve, so you can kind of maybe understand why. And it was a cancer center. And so on our next lap around the hospital, we saw that he had fallen onto the ground. So my dad ran over and helped this drunk guy back into his chair. And he looked at my dad and I, and he said, "Thanks so much. Good luck to you and your wife." We were like, "Wife? What is he talking about?" Then I looked down at my belly and I realized he thought that I was my dad's pregnant wife, which was a low point emotionally for both of us. And I turned to my dad, I said, "Man, you've got an ugly wife." And we managed to laugh really, really hard. I think that if I had been confused as my dad's pregnant wife a couple weeks earlier, I think it would have been hard to deal with. But the reality was that I was feeling better, and I was so thankful to be alive that we laughed really hard about this. So a passage I think fits well here is that facing my horrible moments with laughter was just as fundamentally a rejection of Castleman's dominion over me as anything else I was doing. It cleared my mind, it stiffened my resolve. It was entirely up to me to determine what was and what wasn't funny. Perhaps most important, humor is social. For me and my family, there was never a better way to reset our collective resolve than laughing together. And we just found, for my dad and I, that laughing together was so important during the really, really tough times. And about 7 weeks later, I was discharged from the hospital. So now it's been about 6 months that I had been sick when I first became ill with Castleman disease. And you can see the big belly that I have from the liver and kidney failure. You can see my hair is gone from the chemotherapy. And then this picture is from just a few years before when I played college football at Georgetown. And I always say this is like the worst before and after picture of all time. But if we could flip the order, it would be this like amazing Peloton or Muscle Milk commercial. But unfortunately, they're in the wrong order. So I took a picture every week for the next 8 weeks, and you can see my belly starting to go down. You can see my hair starting to grow back. And by the end of the 8 weeks, I look less like my dad's pregnant wife. I took pictures from the side as well. And so you can see my belly coming down over time, and you can see my hair growing back. So when I got out of the hospital, I decided to embrace the "Think It, Do It" motto, and I reached out to Caitlin, and I told her, how much I regretted that I hadn't fought for our relationship, that we weren't able to spend that time together. And thankfully, she was feeling the same way, and we started dating again. This picture is about a year later. On a Halloween. That's me dressed as Borat, if that didn't stand out to you. And unfortunately, I imagine not everyone watching this knows who Borat is, which is painful to hear. But that's me as Borat, and Caitlin and I celebrating Halloween together. And then this picture, I think, is a really good symbol and representation of Caitlin and our relationship. So on one shoulder, I have chemotherapy. At the time, I was getting an infusion every 3 weeks of chemo to try to keep my disease in remission. And on the other shoulder is Caitlin. So I've got chemotherapy keeping me healthy and alive, and I've got Caitlin on my other shoulder supporting me during what was a really, really tough time. So I came back to Penn for med school, and I was now towards the end of my third year, and I was hopeful that the chemotherapy, I was getting an experimental drug every 3 weeks, and I was hopeful that that would keep my disease in remission. But I knew now for the first time really the challenges of being a rare disease patient. So I decided I would dedicate my career towards studying rare diseases, accelerating rare disease research. And so I got involved in Penn's Orphan Disease Center. And then about a year after my previously being sick, I had a full relapse, and I was back in the hospital, back in the ICU with all of the same organ failure as before, despite this experimental drug, despite kind of our best hope and our only hope for my survival. It didn't work. That drug worked for other people, but it clearly wasn't working for me. And so I had a conversation with my doctor where he explained to me that I had run out of options, that there were no more drugs in development. There were no more promising leads. There were no researchers out there that we could be hopeful would find something. And he explained that I was completely out of options. He gave me chemotherapy, which saved my life. And you can see I lost my hair. But right around that time, I turned to my dad, my sisters, and to Caitlin. And I said, I'm going to dedicate the rest of my life, however long that may be, to trying to identify a treatment for this disease. And when I said that, it wasn't because I actually thought that I was likely to find something. I knew that it was very, very unlikely. And I don't know, I can't believe I'm about to quote something from Dumb and Dumber, but it makes me think about in Dumb and Dumber where he says, so you're saying there's a chance. And I think that I had this kind of 1 in a million chance that I would find something. And maybe it was dumb to think that 1 in a million is enough to say, okay, so you're saying there's a chance, but that was my mentality. And it was realizing that if I didn't do something, you explained to me I had a 0 out of a million chance. But if I did something, maybe I had a 1 in a million chance. And so I decided I would get involved in conducting research into Castleman disease. I had no experience doing this kind of research. There was no lab set up at Penn to do this kind of research. But I persuaded a colleague of mine to provide some space in her lab, and she let me begin conducting Castleman's research. I also knew that I was unlikely to make progress in time to save my life, so I started a foundation called the Castleman Disease Collaborative Network to try to accelerate research on a global scale and get physicians, researchers, and patients all working together. And really what inspired this decision was as I sat there in my hospital bed and I realized I was out of options, I found myself hoping and praying that some researcher somewhere would figure out something that could save my life. And I realized I'd been hoping and praying for many years for these sort of things. I'd hoped and prayed for a drug to save my mom's life. I'd hoped and prayed for the previous 2.5 years that some drug somewhere would be found for me. And I realized in that moment that if I was going to hope for something, or if I was going to pray for something, that I would need to take action, that I would need to say, what can I do today to get closer to that which I'm hoping for or praying for? So a passage I want to read is, hope cannot be a passive concept. It's a choice and a force. Hoping for something takes more than casting out a wish to the universe and waiting for it to occur. Hope should inspire action. And when it does inspire action in medicine and science, that hope can become a reality beyond your wildest dreams. So I got out of the hospital, and the first thing I wanted to do was understand, well, what's going on for Castleman disease? What research is being done? What's known? What's not known? I learned that about $10,000 a year was going towards Castleman's research, which is just really basically nothing. No money from the federal government was going towards idiopathic multicentric Castleman's or IMCD research. There were no patients in a registry because no registry existed. There were 2 advocacy organizations that existed, but neither of those organizations had any sort of a research plan, and they certainly were not working together. There was no diagnostic criteria. There were no predictive biomarkers, so blood tests you could run to predict whether someone would get better on chemotherapy or another drug. There were no cell lines or biobanks or registries to work on and perform research on. There were no treatment guidelines. The disease was very, very poorly understood. There were no FDA-approved therapies, and there was one drug in development, but as I shared earlier, that one drug in development did not work for me. So here I was in a landscape where there was basically no progress except for one thing, and the one thing that was there didn't actually help me. That one drug in development was based on incredible work by Kazu Yoshizaki. Kazu is photographed here doing what we call the Castleman flex. Kazu did incredible work back in the 80s and 90s to determine that one particular part of the immune system, what's called interleukin 6. So your immune system produces cytokines, and cytokines are molecules that your immune cells use to communicate with one another and also to fight off things, like in COVID's case, to fight off viruses or whatever it is the immune system's trying to fight. Well, Kazu discovered that one of those particular cytokines called interleukin 6 was really, really important in Castleman disease. So he set out on this journey to develop a drug that could target interleukin 6 and just neutralize it, completely block this one cytokine so it couldn't have an effect. And he believed that if he could do that, and if he could give it to humans, that maybe it would treat Castleman disease. And I'd heard a rumor that he had given it to himself, given the drug to himself to prove that it was safe before he gave it to other humans. And when I asked Kazu, I said, Kazu, Makoto just told me that you gave tocilizumab to yourself to prove that it was safe before any other humans. Is that true? He said, no, I didn't give it to myself. The nurse, she gave it to me. And I said, exactly, Kazu. So Kazu Yoshizaki developed the drug, tested it on himself, went on to study it in other patients, and it went on to get approval in Japan for Castleman disease. One of the reasons I highlight it is not just because it's approved for Castleman's in Japan, but because it went on to get approval in the United States for rheumatoid arthritis, where it helps thousands and thousands of RA patients. And maybe most importantly, when CART therapy was used for the first time in a child at CHOP, so just down the street, the first pediatric patient to receive CART therapy had an awful reaction to it. Her immune system went completely out of control. It looked just like Castleman disease. So they treated her with this drug, tocilizumab, that Kazu developed 20-something years before, and it saved her life. It saved Emily Whitehead's life. And in addition to the importance of saving this young girl's life, it also saved the entire cellular immunotherapy program. Because if the first pediatric patient to ever get CART therapy had died from this cytokine storm, you can be certain that the entire program would have been shut down for at least 5, maybe 10 years. Thankfully, this drug saved her life, and thankfully this drug, or this approach of cellular immunotherapy, has gone on to really become one of the most promising treatments in all of cancer. And so when COVID-19 hit, and there was a lot of overlap between what Castleman's patients experienced and what COVID-19 patients experience, doctors around the world started testing this drug, this same drug that Kazu developed, tocilizumab, on COVID-19 patients all around the world. And thankfully, it has helped a number of these patients. It's not yet an established treatment, and we're still waiting for the randomized controlled trial data to come out. But there was recently a press release saying that in a controlled trial, it wasn't randomized, but in a controlled clinical trial, that patients benefited from treatment with tocilizumab, patients with COVID-19. I think it's an important lesson to highlight. Those of us that live in the rare disease world, when we do rare disease research, we do it to help patients with rare diseases, but we also know that the work that we're doing is very, very likely to have a much wider impact than just the patients with the rare disease that we develop drugs for. So that's where we were. There was very little progress. The one thing that was working didn't work for me. And so we decided to set out to create a new approach to research. But before we could create a new approach to research, we had to really get a good understanding for how is research typically done. So research typically occurs by groups of patients coming together and raising money, and then inviting researchers from within that field to apply for funding, to use that money for research. A small fraction of the field will apply for funding, and then an even smaller fraction will actually be awarded funding for research. And then they go on to do the work. It's a very linear approach where you fund a study, and then you fund the next study, and the next study, and the next study. It's certainly, each study is reviewed independently of the others, but this is the traditional approach to research. So at the end of the day, what you're doing is you're hoping the right researcher applies for the right project at the right time. And that happens sometimes. Occasionally, all of those things align. Occasionally, Kazuo Yoshizaki comes along and everything lines up. But the majority of the time, it's like waiting for the stars to align. And as a patient with this deadly disease, I wasn't willing to wait for the stars to align. So we created a new approach to research, what we call the collaborative network approach. So the first step was to build a community of physicians, researchers, and patients. We wanted them connected. It wasn't going to be a patient community and a disease community, but we're going to connect physicians, researchers, and patients within Castleman's plus related diseases. So diseases like Castleman disease where we could learn from one another. The next step was to say, not to say we have money, who wants it, but to go to that community and say, we have money, what ideas do you have for how it could be used? And then we'll go out and we'll find the right person to do it. So basically you're leveraging the entire crowd, the whole community, to propose ideas for what research should be done. Then when you go out and you recruit the best researchers to do it, you're really opening, you're expanding the pie. You fundraise for that given study. You procure samples for that study. You begin to conduct research with the top researchers that you've recruited. And something we do that's a bit unique is when we analyze data, we always analyze it with an eye towards what drugs are already FDA approved that may be able to be repurposed or used tomorrow that no one ever thought of before. So it's not just about what's going on in Castleman's, what new drug can we develop, it's what's going on in Castleman's, what old drug can we pull into the mix and see if it could work. Because if it's already FDA approved, you know it's safe and you know it's effective at something. And then we work to try to disseminate this knowledge to the community so the community gets better and better at crowdsourcing, and we as a community do better and better research. I knew that I couldn't do this alone, so I held a webinar very similar to this back in 2012 with a bunch of Castleman's patients. And the disease is named after Benjamin Castleman. He was a pathologist in Boston, but we've repurposed Castleman to be not a person's name, but a castle man. And so this is a picture of a castle man. And so we held a webinar and we showed this picture of the castle man to our community of patients. And about 2 weeks later, this showed up on our Facebook page and we didn't really know what it was. Then we realized this is a tattoo. One of our patients screenshotted the image, got the tattoo in the next couple of weeks, and soon these tattoos appeared all over the world. There must be hundreds, maybe even thousands of Castleman tattoos all over the world. And I think this is just a small example of how our patient community was just waiting for an opportunity to get behind something, and we tried our best to provide that. But it couldn't just be patients. I ended up recruiting a number of classmates of mine. I went to business school at Wharton after I went to medical school at Penn. So I recruited my classmates from both business school and medical school. I recruited local Philadelphians who work at nonprofits and corporations to dedicate hours in their free time to volunteer to be a part of the CDCN. These are just a few photos of people who volunteer to be part of our team. You can see us doing what we call the Castleman Flex. Again, related to this Castleman warrior idea. So a passage I wanted to read was that in the first few years of my battle, I felt like it really was me chasing my cure. But a really important change happened about 2/3 the way through my journey. And that's realizing that it isn't about me chasing my cure. It's really about us chasing our cures, plural. And I learned that if we really wanted to turn the tide against Castleman disease, we needed to expand our effort to include more than just those directly affected by it. More people needed to learn about it so it wouldn't continue to be one of the most deadly, most common diseases that most people have never heard of. And so we reached out around the world. You can see the picture of Kazu on the right and others who joined and became part of our network, physicians and researchers all over the world. You can see our network now is over 800 physicians and researchers that are part of our community, contributing ideas towards research, contributing samples to research, taking care of patients. I didn't talk about the epidemiology of the disease earlier on, but there are about 5,000 patients diagnosed each year in the United States with Castleman disease, which makes it about as common as ALS. And I imagine everyone listening to this call has probably heard of ALS or Lou Gehrig's disease. It's one of the worst diseases out there. But many people have not heard about many other rare diseases like Castleman disease that have a similar epidemiological impact. This is a link where you can see the status of all of our research studies. Something that we also really subscribe to is that we make everything very transparent. So anyone in the world can see exactly what studies are we funding, what stage are they at, what do we need, and you can see, thankfully, many of them are all the way to step 8, which means that they've been completed. Many of them are still in process, but we've been able to make a lot of progress over the last several years. In the midst of our progress for Castleman disease, I graduated medical school. This is a picture of Caitlin and I on my graduation day, and we got engaged right around this time. But unfortunately, just a few months later, I relapsed and nearly died for the 5th time. And each time I've nearly died has been terrifying. I think this 5th time was maybe the hardest because I was so looking forward to May 24th, 2014, and I so wanted to make it to our wedding date. And I knew that I would not make it to our wedding date if I didn't find a treatment. And the reason being is that every relapse of Castleman disease has a mortality similar to playing Russian roulette. So at that stage, I had played Russian roulette 5 times. And no one should play Russian roulette once, but you definitely don't want to play it 5 times. And so I knew that I wasn't going to continue to survive these relapses. And if I wanted to make it to our wedding day, I would need to find a drug, an existing drug. I knew I couldn't develop a new drug in time to do the test and try it on myself. If I wanted to survive, I would need to find a drug that's already out there that is approved for something else that no one had ever thought of trying for Castleman disease, and try it on myself. So I performed a series of experiments in the lab at Penn, so the Translational Research Laboratory, which is just down the road from many of you, certainly from the Science Center. And from those experiments, I found that a particular communication line, your immune system is incredibly complex and it needs to communicate. The cells all over your body have to communicate with one another. And one of the ways that it does that is through this particular communication line called the mTOR pathway. So mTOR is really important for cells to communicate with one another. It's important for them to proliferate, produce cytokines. And the data that I was looking at on my own samples that I had generated in the lab suggested to me that this communication line was turned into the on position. It was almost like in overdrive, according to the data I was looking at. But it was all kind of peripheral data. I didn't have anything solid to prove that this particular communication line was stuck in the on position. And so I performed a really important experiment, an experiment that literally changed my life and saved my life, where I looked at the mTOR signaling pathway in normal lymph nodes, and then I looked in my lymph node. And so this is a normal lymph node, brown. The lymph node stains positively brown when the mTOR pathway is on, it's negative when it's blue. And so you can see here in this normal lymph node that there's a lot more negatively stained cells, so a lot more blue cells than there are brown cells. There's a little bit of mTOR activation. Again, that's brown, but most cells do not have mTOR on in a normal lymph node. And then I looked under the microscope at my lymph node, and I was just completely blown away. So this is my lymph node. And again, brown means positive, blue is negative. And you can just be completely blown away by there was so much mTOR activation. So basically the experiments I had ran led me towards thinking this might be on, but this was a way to show in black and white in front of me that this pathway is turned on. Now, there are inhibitors that block the mTOR pathway, and I immediately started thinking about all of the drugs that block this pathway that we could start testing. But I also realized that just because it was on didn't mean that blocking it would actually make me better. There are many examples in medicine and with people's health where things can be very high and you block them and the disease continues to go on because it doesn't really matter. But in this case, we finally had a lead. We knew that this communication line was turned on. We knew that there were drugs that could turn it off, and we didn't have any other options. So now I think maybe we went from like, you're saying there's a chance 1 in a million to now you're saying there's a chance 1 in 10. And I was excited to move the odds from 1 in a million to 1 in 10. And so I started testing this drug. It's called sirolimus. It was developed 30 years ago for kidney transplant rejection. It basically turns off this communication line in the immune system. And by doing that, it makes it so your immune system and your immune cells can't reject an organ. Like if you were to get a liver or a kidney, it makes it so that your immune cells don't reject that organ or are not good at that. In doing so, it suppresses the immune system. So I said, let's give it a shot. We're out of options. And today marks 78.58 months that I've been in remission while I've been on this drug. You can see how that compares to my previous 4 remissions. So it's about 7 or 8 times longer than my previous remissions. But I say 78.58 months because I know that I can't round up. I don't know if I'm going to make it to 79 months. I do know that I'm really thankful that I've made it over 78 months, and I'm thankful for every fraction. But I can't round up because I don't know what's going to happen tomorrow. I don't know if I'm going to be back in the hospital. But I'm also so thankful for every fraction of a month of remission that I've had. The New York Times called this "Doctor Cure Thyself," which I think is a bit of an overstatement. I think it should probably be doctor helping himself a little bit right now and hopefully for a lot longer. But I don't think that would have fit in the headlines. Thankfully, during this window, I was able to make it to May 24th, 2014. And as you can see from this photo, my hair grew back just in time. So that's never before been cut hair that you see in that picture. It grew back just in time. And it looked like maybe I had a buzz cut for my wedding. And that may not seem very important. And frankly, it's not important compared to whether I was alive or not. But on my wedding day, I wanted to have hair because I didn't want that very external reminder for Caitlin of what I had just gone through with chemotherapy and what I likely would continue to put her through during the course of our relationship. And about 2 years ago, Caitlin and I had our sweet daughter, Amelia. This is our little girl, Amelia. Her name's Amelia Marie Fajgenbaum. So she shares the same initials as my mom. My mom's name was Anne Marie Fajgenbaum. And Amelia keeps my mom's incredible memory and legacy going. So as we think about the impact this drug has had for me, I obviously can't help but think about the impact this drug could have for many, many more Castleman's patients and also for many other diseases. And so what I want to highlight here is that this is an image trying to show that there are about 10,000 human diseases. So each one of these little figures represents one of the 10,000 diseases that affect humans. We know that about 2,500 to 2,700 drugs are FDA approved for about 3,000 of those diseases. So there are basically FDA approved drugs for about 1/4 to 1/3 of all human diseases, but there's just nothing for the other 2/3 to 3/4 of diseases. And so what I want to highlight here is this concept of taking old drugs and using them in new ways. So this is a cartoon of an old dog reading a book about new tricks. And I think that's what we need to do in medicine. We need to not just think about new drugs, but we need to think about old drugs used in new ways. And so out of these 2,500 to 2,700 drugs, how many of them could actually be treatments for many of the diseases over here that don't have any? The same way that I'm alive today because of one of these drugs that no one had ever thought to try. I also am a big advocate for not reinventing the wheel and sharing what we learn from our experience with other groups. That's one of the main reasons why I wrote Chasing My Cure, was to share my journey so that other people, whether you're chasing after a cure for a disease or whether you're just trying to deal with life's challenges, can learn from some of the lessons that I picked up along the way. And thinking beyond Castleman disease again, when COVID-19 really began to hit the States in early March, I found myself, I was actually driving to North Carolina to see my family, and I was thinking to myself, I really hope that some researcher somewhere will follow our blueprint for how we went from no drugs for Castleman disease to drugs. We'll actually look at existing drugs and repurpose them. We'll follow the steps that we did to really understand what's happening in Castleman disease on a cellular and a molecular level. And then about 30 seconds later, I was like, wait a minute. Why are you hoping that someone else somewhere does this work? Like, maybe you should just do it. You know, you're alive today because you stopped hoping and you started taking action, or maybe not stopped hoping. It's because you turned your hope into action. And so I called my lab and I said, you know, what do you guys think? Are you in? And my lab members all said, we're in. And so back in early to mid-March, we decided that we were going to dedicate a huge portion of our center, the Center for Cytokine Storm Treatment and Laboratory, towards studying COVID-19. And we started what's called the Corona Project, which is the COVID-19 registry of off-label and new agents. The goal of it is to identify and track all drugs that already exist that could be repurposed in new ways for COVID-19. And this is just a Zoom meeting early on where we had a team of about 40 people actually call in early on. Now we are over 60 volunteers. Anyone in the world can access the data by going to the link down here. It's freely available to anyone and everyone. We now have a team of over 60 volunteers. Our total number of papers is actually over 14,000 papers have been reviewed. We now have data on over 64,000 patients in our database, have found over 200 drugs that have been used already in COVID-19 patients. So in the news, you hear about the same 5 drugs kind of over and over again. But the reality is that actually over 200 drugs have already been given to patients with COVID-19. Some of those drugs are working, some of them are not working, but it's really important that we keep track of these things. I mean, my mind was a bit blown that this data wasn't being kept anywhere else. I mean, how is no one doing this? And it's only because I decided to turn hope into action that this resource exists. These are 3 of the most frequently used drugs. You may recognize a few of them. We keep this open source and updated, share the data directly with the FDA. And we published our first paper from this work about 2 months ago. And we've got a couple more coming down the pipeline. So I've just got, I think, 2 slides left. This is a slide showing where we were in 2012 with Castleman disease and where we are today in 2020. So in 2012, there's about $10,000 a year going into translational research. Over the last 8 years, we've raised about $1.4 million in total over those 8 years, and we've spent $1.4 million on research. Importantly, that $1.4 million that we spent on research led to an additional $10.1 million of research funding from external funders. So outside organizations said, based on the data that you've generated here, we're going to throw in another million or another 2 million or another $4 million to make it so that the work that you did, we basically seed the work, and then the good work that we seed can then get funding from external groups. My lab got the first NIH grant ever to study IMCD. We now have over 1,200 patients in our registry. We went from there being 2 organizations that already existed to adding our organization, so there being 3, and then being able to work with those other 2 to combine into one collaborative network. Instead of having 3 organizations working independently with independent boards and independent advisors, we said, let's come together into one unified, what we call the Castleman Disease Collaborative Network. We have one unified research agenda. We now have a biobank where we have samples stored from patients around the world. We have a registry where we have patients enrolled from around the world. We've made progress, but there are still many questions that remain. We certainly have not figured out this disease yet. We do thankfully now have a diagnostic criteria. So there are tests that doctors can run to confirm this patient truly has Castleman disease. There's a checklist doctors can go through to confirm the diagnosis. We now have published treatment guidelines. So again, a doctor can say, okay, I've gone through the checklist, you have Castleman's. Now I have an algorithm to say how I can actually treat my patient. We have a series of blood tests that you can run to predict whether you're likely to get better on one drug versus another drug. That drug I mentioned that was in development that didn't work for me, it went on to get FDA approval. It works in about 1/3 to 1/2 of patients. This is research and a drug that was inspired by Kazuo Yoshizaki. And then the drug that I'm on, this drug, sirolimus, is now undergoing clinical trials that we're running out of Penn to see the proportion of patients that it works in. I wanted to show just a couple of the first couple patients that received the drug that I'm on, sirolimus. This is Joey, who was hospitalized at CHOP, so right next door to us, really sick a little bit over a year ago. He didn't respond to first or second line therapy, and then had a really positive response to sirolimus that was really, really special to see, kind of coming in on a day-to-day basis and seeing his blood tests improving and seeing him improving. I hear about the impact of our work often. It's rare that it happens right next door, that I can actually see it on a day-to-day basis. Another local patient is Katie. This is Katie. She was diagnosed before her second birthday, so right around the same age as my daughter Amelia. And she had a really tough go with Castleman disease. For a while, she was taking chemotherapy daily, and we were able to switch from chemo to sirolimus, and she's had a really positive response. I wish that I could tell you guys that sirolimus is working for everyone. Unfortunately, it looks like it works for somewhere around 1/3 of patients. And so the patients it doesn't work in, we are motivated to continue to work as hard as we can to find drugs for them. Today is a really big day for the Castleman disease community. Today is actually World Castleman Disease Day. It's the 3rd year that we're putting on World CD Day. And so I'm super excited that I get to share with you all about World Castleman Disease Day. I hope that you'll go on social media and post about World CD Day, help to raise awareness about Castleman disease. As I said earlier in the talk, we're not going to make the progress we need to unless there's widespread and broad awareness. So I hope you'll be a part of turning our hope into action. Now I'm on to my last slide. Something that's not on this slide is the first lesson I want to highlight. And that's really what I want to do here, is really close by highlighting a handful of lessons from my journey, from chasing my cure. Unfortunately, there are a lot more lessons that I've learned along this journey. I kind of wish I didn't have to learn all these lessons the hard way. But fortunately, I'm really thankful that I'm alive to be able to share them. And I'm thankful that I've been able to share them through chasing my cure. I didn't think I would survive, and I really felt like I needed to get these lessons on paper so that other people could learn from them and not have to go through all the things that I did. So the first lesson is really around overtime. I talked earlier about how I felt like I'm in overtime. I guess I'm in my 5th overtime now. But what I really want to communicate is that we're actually all in overtime. I mean, none of us know how much time we have. All of us need to make the most of the time that we do have. And I think COVID has made us realize kind of how precious life is in some ways. I think that the idea that out of nowhere, this virus can just strike us and make us sick, or make a loved one of ours sick. And that can be really scary. But like I said earlier, it can also be very clarifying. If you know the clock's ticking down, and you don't know how much time you have left, then that can inspire you to make the most of the time that you do have. The next one is that hope can have many forms. I talked earlier about seeing the sign at Duke Hospital that said, "At Duke, there is hope." And I told you guys about the hope that I got from seeing that. And that was very powerful for me to know that, okay, we're in the right place. This is where we should be. And that was the hope that made me feel better about myself, but it did not inspire action. I said, okay, we're doing the right thing. I can feel better, but I don't need to do anything. And I think there's many kinds of hope, but there's another kind of hope where you hope for something so badly that you say, what can I do today to get us closer to that which I'm hoping for? And that's the kind of hope that really is the kind of hope that explains why I'm here today talking to you. And that's because I went from just hoping to taking action. Another one is for the gentlemen, but also the women on the call. And that's that I hope that you're never confused as your father's pregnant wife. But if you are, I hope you can find some humor in that and in all of life's challenges. I think that, you may think that going through the things that me and my family have gone through would make it so that laughing is the last thing you'd want to do. I mean, who wants to laugh in an ICU? But the reality is that I think that that's the time when you really need to laugh with the people you love, even more than when you're healthy and things are good. I think being there, and it's not to say that it wasn't serious or that during tough times you should just laugh about everything. But I think that in the right times, in the right ways, laughing with the people you love is so important. This is a message for any health professionals that are on the call or anyone in the sciences, and that's around the importance of communicating our limits. If my doctor had not explained to me just how dire things looked, if he hadn't explained, look, you're out of options and there's no reason to be hopeful, if he hadn't had that conversation with me, that a lot of doctors don't like to have that conversation. They don't like to have that conversation until they know that, this patient is going to die in the next few hours. But because he had that conversation with me earlier than that and explained to me that I was out of options, but maybe I've got some weeks left. That made me realize that I had time to turn my hope into action. And so I think it's so important for health professionals always to communicate your limits, but I think in particular to do that so that way us patients know if we do or don't need to take action. Another is around this idea of solutions hiding in plain sight. So this drug I'm on, being around for all these years. I mean, to think it was at my neighborhood CVS for all of those years when I was in and out of the hospital, but no one had ever thought to try it. How many more drugs are there out there like that that need to be found? And the last thing is something I mentioned earlier, and that's that my book is called Chasing My Cure, but I really think that was the wrong name. It really should be Chasing Our Cures, because it has been such a team effort from so many people working together. And I'm just so thankful for all the people that have put so much time into this. So thank you guys so much for listening. I hope you guys will now become part of this Castleman army. I hope you'll help to raise awareness about the work that we're doing and also help to raise awareness about Chasing My Cure and our message of hope. Thank you guys.
All right. Thank you, David. That was incredible. So we do have a little bit of time here for questions. If anyone does have any, you can feel free to unmute yourself or enter them into the chat. But while people are thinking, David, I did have a question myself, if you don't mind.
Sure, absolutely.
Cool. Yeah, so I'm not sure if you'll be able to recall fully, but I was curious about the reactions of your friends and family upon your initial diagnosis, and then even when you were going into treatment. Because I know obviously it's all something we're going to have to confront eventually, is the mortality of our loved ones. And, people deal with that in a whole, bunch of different ways. Some people retract, some people, maybe even cling. So I was curious what people's reactions were like, and from your perspective, what was helpful for you?
Yeah, that's such an important question because we all respond so differently to these sort of things. And even within my family, there was just such almost like polarizing contrast between how people responded. So one of my sisters, Gina, her response was to basically, she doesn't have a medical background, but she basically would spend all night, all day, looking online to try to get answers, asking doctors questions. It was kind of why is this lab test abnormal? And at the end of the day, she was just so upset. And that was something she felt like she could do. And so her response was I'm just going to try to learn about the immune system and what's happening and try to help Dave. And then my other sister, Lisa, was equally as upset. They both were equally as upset, but her response was not to dive into the data. It was actually to separate herself from the data. It was basically to be I don't want to know how sick Dave is. I don't want to know why his platelets are so low or what that means. I just want to physically be here in the room with him and not put my brain there. And then my dad had kind of a third approach, was kind of just mad at the world. Why is my son so sick? This isn't fair. Why don't doctors have answers for him? And I think that those are probably three kind of typical ways that people respond. But you can see even within a family how different responses can happen. And I would say from my perspective, I think I appreciated and I acknowledged all three of them. I get it. Like, this is really hard. You're watching your brother die like in front of you. Um, so I understood the all three, but I would say that, and you can probably tell from like the subtitle of my book, Hope into Action. I really appreciated the action part, like the like, why are the platelets low? Like, what's going on here? And so I think that from my perspective, that was most helpful for me.
Awesome. Thank you.
Yeah, absolutely.
Question. You mentioned the collaborative network that you built was a different funding model. I'm curious, what was the biggest challenge in building it? Was it getting buy-in from the other researchers? Was it actually getting the funding, or something else?
Great question. So the funding, it becomes easier to get funding when you do it this way, because basically you raise money for individual projects instead of like, you've probably heard a lot of organizations be like, give us money to cure X disease. And it's kind of hard to like wrap your head around, well, what are they going to do with it? But if you say, give us money to do like this study with these patients at this institution with these details, it becomes a lot easier. Like, oh, if I give $1,000 or if I give $10, it's going to do this or that. So the fundraising part's easier. But to your point, it's actually a lot harder to get the community on board with it, mainly because it's just so different from the way that research is typically done. And so it was really, really hard to get buy-in. I'm pretty certain that we would not have been successful with this new approach if I had not been able to get a number of key colleagues within the community on board with it early on. I think it's an example where, like, if you can identify a handful of allies in something like this that are like really important and that other people listen to, then it's not just like me being like, we're going to change the system. Like we're taking you all down. I kind of got like a handful of people that were like in that sort of oligarchy of medicine and science. And I got them on board. And so then all of a sudden they were doing it and they were following suit. And then other people were like, oh, well, if Fritz is doing it and Tom's doing it and Corey's doing it and Rozelle's doing it, like, I should do it. And so I think a big takeaway that's kind of bigger than Castleman's is that if you really want to like kind of stomp on and completely flip on its head the status quo, the way to do it is not necessarily by like announcing that you're going to be completely flipping it on its head. I'm thinking of like a Trojan horse right now in a way where it's like kind of, getting the right people on board so that it feels a little bit more democratic. And if you get enough people on board that are within that faction, then I think that you can get more people on board.
So at the end of the day, where did you get your initial source of inspiration to kind of say, I can think about this in a different fashion? What was that kind of one impetus that caused you to go for it?
Yeah, good question. I think I probably can't take it down to just one thing. I think I'd say it's a combination of two things. The first is that I think that we're probably our most innovative when our backs are against the wall. And I mean, frankly, I had Castleman disease for 2.5 years before I did anything to fight Castleman disease. I mean, I was fighting it to stay alive, but like I was a medical student at Penn. I actually started a separate foundation years before. So I was kind of like well positioned to do something, but I wasn't doing anything because like, I wanted to become an oncologist. I wanted to like, do the things that I had planned to do. And I wasn't, and I didn't want to like take on this burden or like everyone wants a cure, but no one wants to do the work. Right. And so it wasn't until I was backed up against the wall until I was like, oh my gosh, like, I guess I have to do this. I think that there are a lot of examples of kind of reluctant leadership where like, you don't want to have to do it, but you have to do it. And that's when you do it. And so I think one part was that I was up against the wall and I didn't have any other options. It wasn't like I guess I could have just waited, or I could have gone to like Vegas and just like, lived out my last days. Right. Those are kind of my other options. But I didn't want to do that. And so one part was that I was up against the wall. And the second part is that I had this future that I wanted so badly. Like I wanted to get married to Caitlin. I wanted to have a family with Caitlin. I wanted to have a life where I worked on identifying cures for diseases. And so I think it was both that I was so backed against the wall and I had this future that I just wanted so badly that combination of things led me to take it on.
Well, we have a couple minutes left. David, I just wanted to sneak in one more question if
Sure.
possible.
Yeah,
Cool.
absolutely.
I was curious, like, how has this all affected your reactions to people, who might be complaining about trivial things? Does it irk you, or do you kind of just want to tell them, like, hey, there's, let's not focus on this?
Yeah, I think, it doesn't irk me. I think that what I've learned is that like everything in life is relative. And so, my worst day was like having my last rites read to me and saying goodbye to my sisters and dad and girlfriend and like, while simultaneously dealing with lots of like, stabbing pain all over my body. And so that like became my like worst day. But like everyone's worst day is their worst day. It's not like you can kind of compare one worst day to another. And so I think that I just realized that like we all bring our own worst day to the table. And so like, yeah, I mean, there's things that happen in my day that don't really irk me, that if I hadn't gone through what I did, they irked me before. I mean, I guess my point is that I haven't always been the way that I am. I mean, that's really why I wrote this book, is because like it changed me fundamentally. It changed who I am to my core. And I kind of wish I didn't have to go through all that I did to be changed, right? Like I kind of wish that like I came out programmed to be this way. Like I wish that I was just like born this way, but I wasn't. I was born the way that I was. And then I went through really, really tough times, and it kind of like molded me into who I am. And I don't really want other people to have to go through all the stuff that I did to have to learn those things. It's like, well, maybe I can just like give talks for things like this, or maybe I can write a book and share these messages, and then these messages can get out so that, you or anyone else don't need to go through some of those same experiences.
It's awesome. And I guess that's kind of, that outlook is kind of what led you into a medical career in the first place, really.
That's right. Yeah, that's exactly right.
Cool. Well, this was fascinating and super inspirational, David. Just really appreciate you sharing your story with all of us.
Well, thank you so much for giving me the opportunity, and all of you for spending your afternoon on World Castleman Disease Day of all days with me. So I hope that you'll be tweeting and posting about Castleman disease. It really would mean a lot to me. So thank you guys so much.
Awesome. All right, everyone, thank you for attending, and yeah, enjoy the rest of your evenings and check out some of the other sessions coming up. Look forward to seeing you there.